Join us and change the game.
Join us and change the game. HH2E, what is that? It's a project for the future. HH2E AG, together with Siemens Energy and Uniper, are setting up a project together at the Hamburg-Moorburg location. Now let's hear more from Hanno Balzer about how they're going to proceed. He's the head of the energy industry segment of HH2E. Thank you very much, Mr. Castor. I hope you can hear me. Yes, we can hear you. I'm very grateful. Now, I'm delighted to have the opportunity to briefly present our concept for the power plant of the future called in Hamburg-Moorburg. It is iconographic. It is not going to be only based in Hamburg-Moorburg, but everywhere where fossil fuel-based locations are located. So the basic idea of HH2E is that primary energies from wind and solar are available. Low-cost energy is available, and that it's really only about feeding and integrating renewable energies into the system. System integration is the buzzword that is relevant to HH2E. I'd like to follow up on one of the statements made by Mr. Maubach. He mentioned the PV electricity price in Dubai, which is just over 1 cent per kilowatt hour. When I started in the energy industry, lignite cost 30 euros per ton. That was about 30 marks per ton, 15 euros per megawatt hour. At the time, we succeeded in generating electricity, process steam, and district heat from lignite, and we should also be successful in using the cheapest primary energy, that is electricity from renewables, to use renewables to create energy. We have 3 system components. Number 1, an innovative electrolysis. It can be charged within 4 hours and discharged over 16 hours. Hydrogen can be used over 16 hours. We have a high-temperature storage facility, which has the same basic principle. Charging in 4 hours, and process steam is then made available over 24 hours. And then finally, we have an innovative gas turbine, which during the few hours when wind and sun are not available, the gas turbine is available for electricity production. So that's the concept of this power plant. So the partners seem to really be working together. 4 hours of charging, 24 hours of supply. So this is being applied in Hamburg only, and then it will be rolled out across the Republic? Yes. We have many locations where steam and electricity is produced on the basis of renewables, on the basis of fossil fuels, and that's where these new power plants are to be based. And this is really Industry 4.0. And let's continue with a keynote by Professor Andreas Pinkwart. He's the Minister of Economics of the state of North Rhine-Westphalia, the state in Germany with the highest population and the highest amount of industry, and also the state that has the candidate for the CEU, the Chancellor's candidate. And this candidate will probably also have to talk about the energy transition. And at some stage in the keynote has been recorded by video, and it's Andreas Pinkwart.
Ladies and gentlemen, as North Rhine-Westphalia's Minister for Economic Affairs, Innovation and Digitalization and Energy, it's a real pleasure for me to be able to give the keynote address before the virtual panel discussion, in which such outstanding panelists as Ms. Grimm from the Council of Experts or Dr. Eickholt as a member of the Managing Board of Siemens Energy are taking part, as well as all the other panelists whom I would also like to welcome very warmly. Today is about hydrogen. Hydrogen is certainly the key to the greatest challenges and opportunities facing Germany as an industrial location and also the industrial regions of Europe and the world. What we need to do in view of the Paris Climate Agreement and the goal of climate neutrality by 2050 is to fundamentally rework and realign our energy systems and at the same time fundamentally transform our industries, and all this in less than 29 years. This is the time we have left from today to achieve climate neutrality. For us in Germany, it has become normal in recent years for it to take 25 years to get a bypass road project completed. And now in 25 years, we have to largely rebuild the energy systems of our country and the industries of our country. So that is a huge challenge. But as the minister has been closely involved with the issues in North Rhine-Westphalia for the past 4 years, I do see that we have the best conditions in Germany if we really use them courageously and also boldly to turn this challenge into the opportunities of the century. And hydrogen offers a very central solution here. Hydrogen opens up opportunities for us to better balance an energy system that will be based exclusively on renewables in the future. If we have excess capacities, they can be used for conversion into hydrogen. And this makes hydrogen also a storage medium for the energy system of the future. And if the conversion and possibly also the reconversion are sufficiently efficient, it can, of course, also help to build bridges in a system with increasingly volatile supply. On the other hand, hydrogen also makes an important contribution to decarbonizing production processes that we know today in industry. For example, steel production, where we can replace carbon-based reduction processes with hydrogen. But we can also use hydrogen in the heating sector, which is also a very important field of the energy transition. And we can use hydrogen to solve our mobility issues of the future even better. Of course, we are focusing very strongly here on electricity-based mobility. This applies in particular to passenger car production in the future, which will be mainly battery-powered vehicles, but we also have strong commercial vehicle sector. We have rail, we have transport, we have shipping, we have other areas where we have to transport heavy loads. And here, hydrogen offers itself as a very important enabler. So you see, hydrogen is an intermediary, if you will, of the energy industry that helps to combine the energy transition and the industrial transformation in a very excellent way. And Germany, with its industry, is already familiar with hydrogen by tradition. I can say this from North Rhine-Westphalia, where we have learned to work in an excellent fashion with hydrogen in our industries for around 100 years. We also have the infrastructure in this area, so our task will be in future to produce hydrogen, which up to now has been mainly based on fossil fuels, in such a way that it meets the climate targets. So from the various hydrogen colors that exist, we must gradually move at least in the direction of green hydrogen so that we can achieve our ambitious climate goals by 2050 at the latest. And then, of course, if the hydrogen economy as a whole is to function across sectors, we have to look at the sources of hydrogen production. We have to look at hydrogen production itself, and this requires specific technologies. For example, electrolyzers that are needed here. There are already some great developments here, but of course, we are still looking at prototypes and living laboratories. Of course, we also want to develop electrolyzers for large-scale use and also deploy them in Germany, North Rhine-Westphalia. We're talking about gigawatt-sized plants here, and these plants should, of course, be fed with renewables so that the generation process is climate neutral from the very start. That, of course, produces some demands, and here I'm talking not only about the generation, but also about the grids, about the infrastructure we need to transport hydrogen to the places where it can best be used. And we are already in talks here with the grid operators in Germany about getting renewable energies not only via power lines to North Rhine-Westphalia from the coast, but where offshore wind energy is converted. So we are planning hydrogen pipelines to install the electrolyzers right on the coast and then to be able to transport hydrogen produced in this way via appropriate pipelines to the industrial regions in the west, the southwest, the south, and other parts of the Republic. In order for our industries to be competitive in future and in view of the quantities of hydrogen needed, it will not be possible to produce all of the hydrogen in Germany only. We will also have to import large quantities of hydrogen going forward. And we are working on this with our European neighbors that have specific capabilities in this area, as well as more distant destinations where we have particularly favorable conditions for renewable energies, and also find the willingness to invest in these renewables. Also, in order to achieve a transformation there from the oil industry to the renewable industry of the future, and to continue to supply Europe, Germany, and North Rhine-Westphalia with renewable energy as hydrogen, which can then be used here for the various purposes. And that takes us to the areas of application that I already mentioned earlier in the various sectors, from industry to the energy sector, to mobility, and even to the heating sector. Many applications are still being developed and open up a wide range of possibilities for us as a country of innovation, as a country of production and industry, and as a country that is transforming itself to a climate-neutral industry and society. And that is so urgently dependent, a country that is so urgently dependent on these innovations and technologies. Yes, hydrogen has a great future. We here in North Rhine-Westphalia are firmly convinced of that, and that is why we have presented a hydrogen roadmap for North Rhine-Westphalia with very concrete medium and long-term goals for our federal state, and with very concrete initiatives to advance production, transportation, and also application as quickly as possible, because we know, ladies and gentlemen, the clock is ticking. As I said at the beginning, we only have 29 years left. In reality, it's only 9 to 15 years, because our industries have to be able to adapt more quickly. They have to make use of the new opportunities more quickly, because we have long investment cycles. And once again, we are ahead of the game. We can still be among the innovators who develop the best technologies for production, for transport, and for use. That will open up great opportunities for us, and at the same time make our industrial location fit for the future. We are therefore very pleased about this event, about the subsequent discussions, and about the fact that Germany is now really setting out to make hydrogen a major enabler for shaping the energy transition and for effective climate protection in the future, where industry, economy, environment, and climate are not in opposition, but where we mutually reinforce each other, where we can use climate protection as a driver for the modernization of our industry, and where we will also seek and find our competitive benefits, our advantages, our competitive edge on the global market. So in this sense, I wish you a wonderful event, a great event, a successful event with many suggestions and ideas. We from North Rhine-Westphalia are at any rate at the forefront of hydrogen and look forward to your suggestions and also to your recommendations. Thank you.
Vielen Dank, Andreas Pinkwart.
Thank you, Andreas Pinkwart. He won't be hearing it, but he will probably hear about it in whatever way. A Free Democrat and the Minister of Innovation in North Rhine-Westphalia. The Tagesspiegel has the motto Rerum Cognosis, finding out the reasons for what is happening. He was speaking about hydrogen just now. We want to understand things, and the discussion which is about to take place is the panel discussion on the hydrogen Republic of Germany, and I welcome my colleague Jakob Schlandt. He will take over from now, so I'll hand things over to him now. Thank you.
Thank you very much, Mr. Kastorf. It's me again. I'm back. And for those who hadn't attended earlier, I'd like to briefly introduce myself. My name is Jakob Schlandt, and I'm going to be the moderator of the next panel discussion, and the title is The Hydrogen Republic of Germany. And we would like to now find out together whether these two words are associated with a large or a small question mark or with an exclamation mark. And we would also like to examine the regulatory questions and the political decisions that have to be taken. Some of them might be contested, some of them are very contested. Now, I would like to welcome, as the first guest in the studio, Jochen Eickholt, the board member of Siemens Energy AG. Siemens Energy AG is also based in Berlin. And I just heard that you still operate a lot in Munich, but that you are also in Berlin. Happy to have you here. And I would like to remind you that you can ask questions to the right of the stream. And the panelists will hopefully be able to answer the questions. The last 15 minutes will be dedicated to your questions. Now, let me welcome the virtual guests as well. And let's see. Looks good. All five are available. No problems. I'll start at the top left. Professor Veronika Grimm, a warm welcome to you. Mr. Pinkwart already addressed her. She's a member of the German Council of Economic Experts. The council is also known as the Five Wise Men, Women, Economic Wise Men, Women. And she's also a board member of the Zentrum Wasserstoff Bavaria. Another panelist is Professor Kirsten Westphal from the Stiftung Wissenschaft und Politik. This foundation does a lot of research work with regard to international questions. The Federal Chancellery funds this foundation, and she's also a member of the National Hydrogen Council. A warm welcome. Tobias Goldschmidt is the State Secretary in the Ministry for the Energy Transition, Agriculture, Nature, and Digitalization of the State of Schleswig-Holstein. A warm welcome. Frank Peter, the head of the Industry Department at the Agora Energiewende think tank. All of you who know more about energy issues should probably be familiar with Agora. He also coordinates the activities of the industry program and chairs the team Germany. And finally, André Walter, the chairman of the management board of Airbus operations, and he's also the manager of the plant in Hamburg. And we will hear more later about the activities in the area of hydrogen. Now, please bear with us for a few minutes, because we're going to start with a question for the audience. You will be able to decide, or we have two questions for the audience. It will take some time until the results will be available, and we will look at the results together in a few minutes.
So, jetzt Wird Deutschland zur Wasserstoff...
Is Germany becoming a hydrogen republic?
Ist mir das zu klein da vorne? Wird Deutschland zur Wasserstoffrepublik?
Is Germany becoming a hydrogen republic?
Englisch sprechen, is Germany becoming a hydrogen republic? Das ist die erste Frage.
That's the first question.
Wir sehen, es ist so ein bisschen wie bei
It is similar to the situation for Mr. Laschet yesterday.
Vorsprung, aber kein
A
überwältigender
clear advantage, but not a dominant
auch ein.
situation.
Skepsis ist mit die 40%.
It looks like there is still some skepticism, and which is quite pronounced at 40%.
Zweiten Frage.
Now let's continue with the second question, please.
Wo kommt der benötigte Wasserstoff her?
Where does the required hydrogen come from?
Wir werden den Wasserstoff hauptsächlich aus Deutschland
We
und dem
will
Nahen Ausland beziehen. Ist die erste
mainly get hydrogen from Germany and neighboring countries. Or, second option, the majority of hydrogen required will have to be met by overseas imports. And by the way, that is
so formuliert ist.
has been expressed in the hydrogen strategy of the Federal Republic of Germany, of the government. Now, the consensus seems to be a bit stronger here. Well, 2/3 believe that the majority of hydrogen required will be provided from overseas.
Mit dem wir jetzt einfach in die Diskussion starten. Die Experten
Now, it's quite interesting
werden sich sicher ihre
image, and the experts, the panelists will probably also have formed their own opinion. And I'd like to start with the discussion. The Hydrogen Republic of Germany is the title of this debate. What do you believe? Do you think hydrogen will play a complementing role, or will it be a dominant energy source which requires input materials such as renewable energies, but that will be dominant in terms of an energy source? What is the opinion of Siemens Energy in this regard? We believe that it cannot be dominant in the short term. However, in the medium and long term, it can play a very important role. And it will not only be hydrogen alone as an energy source, but also follow-up products, synthesis products, ammonia, e-fuels. I think there's going to be an ecosystem-like situation. But nevertheless, at the end of the day, it will be based on hydrogen, and hydrogen will definitely play an important role in our future energy system. Professor Grimm,
Professor, wie dominant wird die Rolle?
How dominant will hydrogen's role be from your perspective? I think there will be a paradigm change in the energy industry and in climate policy. With climate targets will require a change, and hydrogen will not only be important for energy production, but also in industrial processes. It will be imported to a great extent, and value chains will be shifted. That is, ammonia as an energy carrier for hydrogen, or steel, which would be imported in the future. And on the other hand, there will be many opportunities in industry because Germany has a very good position when it comes to producing hydrogen, but also the value. German industry can create value by applying electrolyzers, developing electrolyzers, storage systems, etc. And this will definitely lead to a fundamental change in German industry. Thank you very much. Mr. Goldschmidt. You're basically at the source. You're state has a lot of renewable energy, and you are forecasting a great future for renewable energies. They can either be used for electrification or for producing hydrogen. Do you think hydrogen will play a dominant role? Well, whether Germany is going to become a hydrogen republic or not, then I would say I hope not. It would not be healthy to focus on only one technology. You have to be open towards a wide range of different options, and I don't think a technology as such should be a governmental target. But I agree with the previous speakers in saying that hydrogen will play an important role on the path towards decarbonization. Mr. Pinkwart also said that it will be a game changer and the industry will be able to do a lot with hydrogen and will also be able to define the future of Germany as a location for industry, Schleswig-Holstein as a producer of renewable energies, and as a location for hydrogen projects. Now, I'd like to change the question slightly and say that I don't want Germany to become a hydrogen republic, but a republic of climate protection technologies, hydrogen included. Now, whether you use hydrogen directly or use hydrogen as a gas, that's something that is no longer that relevant. We should really use the energy that works best and is most efficient in the various sectors. And in some areas, this may be hydrogen, and in other areas, it's direct usage of electricity. And I think we should leave this up to the market. You're right. This topic has really been discussed widely, and we don't want to regress, really. But in order to create and design an infrastructure, you do need a clear idea. You can't leave things undecided. You need targets when you develop the infrastructure. Now, Mrs. Westphal, what is your opinion? How dominant will hydrogen's role be, or will it play a complementary role? Well, I do believe that hydrogen is going to be an important pillar in the process of coupling sectors and also for the stabilization of the overall system. You mentioned infrastructure, and it's extremely important to think in terms of electricity, gas, and hydrogen infrastructures as one infrastructure. And the previous speakers said that we need a change, a paradigm change. It's not about replacing an energy source by another one or substituting fossil fuels, but it's really about using an energy source that is associated with complex previous processes or input processes. It constitutes a particular challenge for Germany as a location for industry. This mechanism requires an intense debate in Germany. The same question to you, Mr. Peter. Is it overhyped or undervalued? You've been dealing with this topic for some time, and Agora has published various studies on the topic of hydrogen. What's your opinion? Hydrogen will play a dominant role, however, not in all areas. As it is the case with multi-talents, you at one stage have to focus on your strengths and in order to be strong in one area and to be used and not remain a talent infinitely. Hydrogen should be especially used in industry applications. That's where the focus should be, because we don't see very many alternatives. In terms of electrical solutions, we need it as a reduction agent in the steel industry, as a feedstock in the chemicals industry in order to be able to produce high-value chemicals, and in the development of ammonia production, that's where we need hydrogen as a resource and as a feedstock. That's where it will be indispensable. We will also need it in other sectors where we need where we produce district heat as a backup in the electricity system, the heating system, as a fuel in aviation, in shipping, or in heavy cargo. However, there is strong competition with electric batteries. However, in the low-temperature applications and heat, we have electrical solutions that are competitive, also from a competitive point of view. And here we do not see that hydrogen will be used in all areas in the future. Hydrogen will be an important pillar in the energy transition, however, only in focused areas.
Okay, let's come back to heat supply here. Dr. Balzer,
Airbus.
You from Airbus. I'm putting this question to you because you have to argue from the customer's perspective. You want to use hydrogen. In 2035, you want to have the first hydrogen airplane, hydrogen-powered airplane. So what are your expectations? And maybe you can give us insights where you will be needing hydrogen. Do we expect that all major airports will have to be supplied by hydrogen? Yes. Hello, everyone. To everyone. From our perspective, there are no alternatives to using hydrogen in the long term for aviation. And for us to be able to do so, we need the infrastructure. And we will not achieve our goals in aviation, our climate targets in aviation, which is to reduce our emissions by 55 based on 22 without hydrogen. And this means that we need a hydrogen infrastructure which is available at all major airports. And we will only achieve that if we start early enough. So from my perspective, announcements alone won't be enough. We now have to start implementing these things. Let me stay with you for my next question, because aviation is a special case. In Hamburg, you will be getting hydrogen sometime soon if the HH2E project takes off and is funded as required. Will that be your first refueling station, so to speak? There are many initiatives here in Hamburg. That's one of them. There are others as well, but clearly we as customers would be pleased to see these initiatives take off and to be able to purchase our hydrogen there. And yes, that would be our first refueling station, providing we have the right infrastructure in place. I'd like to come back to the point mentioned by Mr. Peters. What are the limits? Where can we say hydrogen does not make sense? Mr. Peter, you just said for heating, for heating supply to residential areas, you said it's not a good area to use hydrogen. Electrification and heat pumps would be the better option there. There is this quarrel going on, and Mr. Feicht positioned himself the other day by saying in the heating sector, hydrogen would only be used after 2030. Maybe you can enlarge on that very briefly, if you can, and add to what you said earlier. Why do you think that is where the red line should lie? The interpreter apologizes, no sound. Mr. Peter? Sorry, I had to unmute myself. From an economic and ecological perspective, there are very clear limits. For low-temperature heat, we have electric concepts which are competitive already from an economic perspective. And when it comes to heat, you need to differentiate. It's not that we won't use hydrogen at all for heating. Hydrogen will be used in combination with district heating systems where we have concentrated infrastructure to involve broad resources of heating sources. And during the heating season, hydrogen will be used as well. But we don't see hydrogen in the low temperature applications. And we don't need a small local distribution grid. Also, from a cost perspective, that's not viable. If we have electric alternatives that are much more affordable. So if you have hydrogen clusters around industry or transport nodes, then, of course, hydrogen can play a certain role, provided the infrastructure is there, and maybe even for heating as well. But this would be things that would result naturally because clusters develop the way they do, and not because they are pushed, they are funded from today's perspective. Thank you. So that is a question I would like to put to the whole panel, to all of you, to the 5 other participants. Would you like to comment on Mr. Peter's position, to draw a line there? Would you contradict that? Let me assume the opposite position here. Do you actually represent that, or is this just an intellectual exercise? No, I'm a little more open here, particularly given the background that we need to make sure that we use the forces our market economy to bring hydrogen forward in areas where opportunities are, not just areas in terms of hydrogen use, where I think what can be substituted, what can be done in a more climate-neutral way. But we also need to look at what will disappear in terms of value creation and in terms of opportunities in mobility, heat production and industry, and what will be created as a future market going forward. We're not seeing that so clearly today because these future markets are not there yet. They still need to develop. So we need to be careful here and not think about hydrogen in terms of substituting other resources used today, but also look at the wider future picture. And we also need to look at what a possible transformation path could look like, where the German economy can create value, can use value potential by developing a hydrogen solution and giving them a chance on the markets. And one step would be to develop the infrastructure for heavy fuel vehicles. If you compare that to infrastructure driven by overhead power lines, you would see that the ramp-up is possible in a way where the market development would be, market economy would become involved. We are seeing in Switzerland that 50 hydrogen lorries are already being used, and more than 1,000 have been ordered. So there could be a transformation, a quicker transformation in heavy mobility than other more time-consuming projects, and they would allow the participation of private businesses, particularly in clusters that could be linked up, and in that way, infrastructure could be ramped up. And as far as mobility is concerned, yes, a lot will be mobility and electric, but when it comes to full coverage, this kind of blend of electromobility and hydrogen will help, because it will cushion off the burden on the whole system, which we'll be confronted with once we've achieved the full switch. So in these areas, there are arguments for banking on both. And I would say that we need to drive the infrastructure as quickly as possible to support the ramp-up, because the ramp-up both of battery electric mobility and hydrogen mobility comes with value creation, a lot of value potential for the German for the German industry. We need to transform our whole industry, and this value creation means jobs, and we should not just focus on one area. You've already mentioned the next mobility, where the red line lies there, so it was okay for you to speak a little longer about this. I didn't interrupt you for that purpose, but Ms. Böhm made the next point. So back to the whole group. We've talked about heat, we've talked about mobility. Do you see different assessments there? Mr. Goldschmidt, the word is yours. I'd like to add to what Ms. Grimm just said. I could identify with her statements on mobility more than heat. As far as heat is concerned, technologically it's very clear. If I look at new buildings, then the supply temperatures required are not that high. So heat pumps are always an option. And if I have a heat pump, then I can get 3 or 4 kilowatts of heat from 1 kilowatt of electricity. And if I use hydrogen there, then 1 kilowatt of electricity is turned into half a kilowatt of heat. And if I look at the building stock we have today, we have the option of heat networks where you can use electrolyzers or even hydrogen in peak times. So I cannot really see why it would make sense to use hydrogen for heating. And Mr. Schlandt, you just said it. At one point, you have to decide, and this would be, unless we have new findings that would convince me otherwise, then I would say hydrogen is better placed in aviation, Airbus, or the heavy goods transportation sector, because the fact is renewable energies will be a scarce good for a long time to come. So we need to have the courage when it comes to heat. Let's not focus on that. Mr. Balzer raised his hand next, and then Mr. Westphal, and then Mr. Eickholt. Mr. Balzer, please be brief if you can. Okay, I will try and be brief. I'm pleased about Mr. Goldschmidt's statement, because we in aviation have no alternative. And therefore, for us, it's inevitable to further develop the infrastructure there. You said yourself that that we want to have the first hydrogen-powered airplane by 2030, and by 2050, the first bigger one. So for that, we need signals that the infrastructure will be built up. If it's not built, no customer in the world will buy such an airplane. And for that reason, in some areas, we just have to get our priorities right and push the infrastructure. Mr. Westphal, please. I'm with you as far as the industry is concerned and as far as mobility is concerned. But let me come back to heat for, just quickly, because I'm torn here between two opposite sides. It's clear that if we look at optimization models, then electrification makes sense for the heating system. But there could be areas where we need to look at the speed of the decarbonization versus the depth of decarbonization in the heating sector. That's one point. And the other point would be the difficulties in the heating sector are that we have many small actors who we have to convince to renovate buildings and make them more energy efficient. And we have barriers there already. So, if we, it cannot be rolled out, as Mr. Peter said, but there's a new energy landscape, and we will have local communities, parts of cities, where hydrogen will be used, not just for district heating, but in individual buildings as well, because large investment can be made easier here as opposed to individual homeowners. So we have a lot of companies that need process heat. So yes, industry first, and the heavy goods transportation sector, but I wouldn't rule out heat altogether. You see, it's a very hotly debated topic where the process of orientation is still ongoing. Thank you. Let me come to one aspect here, and that's the fact that hydrogen and hydrogen generation, if you will, isn't something today that lives up to industrial expectations. So in many areas, we're still under development of processes, infrastructure, and many other things that are required. The only thing that is clear is that hydrogen or follow-up products will be needed to an extent not seen before, ever. And having too many facets of what's being discussed at the moment means that what needs to be implemented is what we've said just now. What is key is what is affordable and what is economically viable in this context. And the use of hydrogen in many of the applications mentioned isn't really economically viable. And the question is, how can we get there to make that economically viable? And this is why it's key and important to look at the whole hydrogen cycle, the production cycle. But even more important is that we, as Germany, would be well advised to turn hydrogen into a real market, to have market powers that drive something big, and so that hydrogen and the follow-up products are products that can be commercially traded and subject to commercial conditions. So many of that, what's been mentioned today, will be used. If we look at the production of hydrolyzers, for example, today, we have electrolyzers of up to 100 megawatts at the moment. So in 2022-23, these would be the typical electrolyzers. Maybe a little bigger, and we will probably need another 4 years to ramp it up to the gigawatt range. And then you can imagine with gigawatt, we have the kind of capacity that's supposed to be green, possibly. That poses the question, where is it supposed to come from? For example, from the regions where renewables are cheap. But I would like to clearly say that we need to scale up the technologies as quickly as possible. But also, as Germany, we should think in terms of markets and create the market here and get as fast as quickly to a point where hydrogen is usable. And that, I think, isn't a priority at the moment and not really conceivable in the actions undertaken by many of the players. Well, yes, that takes us to the next topic we would like to address here. Market is a word easily used, as though this was something natural. It isn't natural. It's subject to rules and regulations. The Hydrogen Council was furious. The debate about taking electrolyzers out of the EG charges. The charges are used to finance the renewable plants, wind turbines and solar plants. And if the electrolyzers are exempt here, then their competitive position becomes better in one go. That would be, or that is a big stumbling block regulation here. So the ultimate decision hasn't been taken here. Ms. Grimm, maybe you can quickly describe what would be optimum regulation as far as you're concerned. So with EG or without the EG, or what other framework conditions are needed for this, for such a market? Well, yeah, I believe here we just do not have to only think in terms of hydrogen. We need a regulation landscape that serves climate protection, and the market forces have to be enabled to allow climate-friendly market models of whatever kind. And this includes a stronger focus on carbon pricing and a reduction of charges on power, because we achieve decarbonization by using more climate-friendly power to promote heat, to decarbonize industry. And if this if this path of sector coupling is expensive because electricity is expensive, then we have an adverse environment, and then a lot of funding will be required to move forward here. This will then be a slow process, particularly for the actors who have got ideas. So this exemption is great, but generally the EEG charge should be got rid of altogether. But EEG isn't a subject we can discuss here. But that's an important point, nonetheless. And the quicker we are there, the better. And the less funding will be required, and the quicker will economic viability be achieved. And then it will be decided here and there whether hydrogen is attractive or not, or whether there are other options as well in sector coupling. This is something for competition and industry to resolve. With less funding, this would be a sensible development. So no EEG funding anymore, no EEG charges. So we at least have the consensus that it shouldn't be high. But special conditions for hydrogen, like the exemption, would anyone want to contradict that, or do you go along with that?
Yes, I agree with that. No objections, and like the previous speakers said, an intelligent structure for subsidies and regulations would definitely be helpful. And that also relates to or includes subsidies for research. Currently, we fund research in the area of hydrogen technologies. However, the basic technologies for lightweight construction in order to save energy consumption has to be continued. Now, with regard to the criteria for EEG exemption, it applies that this should only be applicable to hydrogen. If you have you also have to have a PPA. You have to deliver the electricity to the electrolyzer, and it's really difficult to get this going. If there is should there be a general exemption from the EEG, the Renewables Energy Act? How should the architecture look like? Are we on the right track? I would support what Professor Grimm said. I would not spend political capital on creating incentives for hydrogen exemption. I would reform the grid access fees and grid utilization fees. That would be the best thing. That's what we should focus on in political terms. We should not talk about exemptions, really. Of course, for a limited period of time, this might be possible. And I would also like to say that it's often quite difficult to get rid of exceptions. Currently, we have a lot of exceptions, and that makes it extremely difficult in the long run. And that's why I would be careful when it comes to moving in this direction. I would support what Professor Grimm said, and I think that network access fees and levies should be redesigned completely. Now, I apologize for digressing. I would like to address a question now that is of a more general nature: own production as compared to imports, and if we import hydrogen, what type of imports are significant? Could we possibly do without importing 80% of hydrogen? And if so, where would the hydrogen come from? I would like to ask you, Mrs. Westphal, as an expert for international relations. Well, I don't think we can really do without that, because we already import 70% of our energy supply. I don't think autonomy or being self-sufficient is a target. It's important to keep up these energy relationships. And it's really difficult to decide which countries should be focused on first. However, we already have energy partnerships. And I do believe that we should focus very much on Europe as part of the European Green Deal. That's quite obvious because of the transportation costs and because we have the same framework of a legal framework and a framework of standards. Hydrogen Europe asked for 2 times 40 GW, that is in the EU, 40, and then in the neighboring countries of Northern Africa and the Ukraine, because we have existing infrastructure and because we have institutions where we can discuss regulation. That would be 80 gigawatts in total. That's the maximum electricity consumption in Germany. And you talked about electrolyzer capacity. So half of this would then be produced within Europe, and another half would be the capacity based outside of Europe. That would be the target for 2030. Yes, and other countries that have a lot of renewable energies and that also have experience, such as Australia, Canada, Chile, where you have a lot of solar and wind resources. So you could, of course, look across the entire globe, but primarily it would make sense to investigate in Europe and the neighboring states. If you reflect on Europe as a location for industry, then cooperation within the EU is a priority. Now, what about the other panelists? Do you agree, or would you like to add something? There's even been talk about converting Nord Stream 2 to hydrogen. Whether this is viable remains to be seen. Mr. Goldschmidt, you would like to make a comment? Do you? Yes. I can agree to what Mrs. Westphal said, but there is a risk that was also mentioned by Professor Pinkwart. We have to speed up, and it would be fatal if we said that we imported hydrogen and then decarbonization will happen without any further activities. So we should be willing to install a maximum amount of renewable energy so that we can produce a large amount domestically. We calculated the production costs, and we said that by 2030 we should be able to have sufficient green hydrogen domestically at viable prices. However, anything above this limit will probably meet with acceptance problems because a huge amount of renewables will be required. And if Airbus is able to have to make the first plane fly, then we will have to recalculate the figures again. At the beginning, we should have the aspiration and target of producing a maximum amount domestically. Now, thank you very much. I would now address the questions of the audience. There was a question concerning where and when green hydrogen would be produced. I think we already addressed this topic, at least briefly. And another question that I would like to ask Siemens as a turbine manufacturer. Can today's coal-fired power plants be converted to natural gas production and then be prepared for hydrogen? Is there a staged concept, or would you recommend a quick change? Yes, it is possible. We could imagine converting a coal-based power plant, converting it and equipping it with gas turbines. Our gas turbines are able to run on 30% hydrogen. We have some that even go up to 60%, and we have others that will go up to 100% in 2030. So there's a rollout plan, an underlying rollout plan, and that's extremely important. If you imagine that at various locations in Germany and Europe, we want to move away from coal to a greater extent than currently planned. Of course, this is a national decision, but it really goes into the gigawatt range. However, if there is a high demand for electricity, you have to make sure that this demand is met. And we believe that renewables will not be able to close the gap that quickly. And that's why we feel that we will need intermediate steps in technology. However, we still will have some time until 2050, and there really is no other way of closing the gaps properly if you take the targets for 2030 and 2050 seriously. We have to be open towards a wide range of different technological options. We have to be prepared to accept transitional technologies and to support them, to develop them further. At one stage, there will certainly be a coexistence of various pillars in energy production. However, hydrogen and renewables alone will be very difficult, and a lot of people don't really have the imagination to believe that this will be possible in the near future. Looks like the North wants to speak up again. Well, this is an area where we have a lot of renewable energies, and that's probably also an area where hydrogen would be imported. Mr. Lutschak from the Kiel University of Applied Sciences has several questions. Let me summarize them. He's expressing skepticism, saying that the hydrogen industry might be over-subsidized like the PV industry 10 years ago. Why are we talking about hydrogen now, although it is only required for the last 10% of the energy transition? And why don't we simply let the emissions trading system take effect? If you have a price for carbon emissions, an investment would make sense, wouldn't it? Wouldn't it be economical to invest in this area? Would anybody like to give an answer? Would anybody like to support and defend hydrogen in this regard? Mrs. Grimm. Sorry, you just spoke at the same time. Mrs. Grimm, please. Well, I think we should make sure that we don't only achieve the last 10%, but that we prepare ourselves well for setting up a hydrogen system, open up new opportunities. And of course, we have to make sure that we don't over-subsidize in many dimensions. We have to learn from the past. We have to set up mechanisms that prevent this. Emissions trading was mentioned. That really makes sense to strengthen the emissions trading system. However, we can't really strengthen it across all sectors in Europe and then solve the problem immediately. We will still have the question of whether we will be able to increase or to ramp up the topic of uniform prices. What about the outside borders if the global partners don't agree? However, I do believe that the ramp-up has to be successful. We don't have to do everything immediately on the basis of green hydrogen. You can also reduce steel and use gas and switch to blue and then green hydrogen over time, make the industry hydrogen ready. We will certainly have a good path that maintains the opportunities in the energy industry as well, and in the industry, as well. Well, the challenge is that we have to take the investment slot or time frame into consideration. The steel industry will have to take investment decisions in the near future. Either they will have the technology available or they will invest in old technology, which would eventually lead to stranded assets. or the steel industry moves elsewhere because they don't get the subsidies or they're not able to invest. It's important to keep reinvestment time slots into consideration. We will have no other chance than in establishing a hydrogen economy before 2030, and these are decisions that we have to take now. And in the next legislative period at national level and in the current period at European level, we will have to pave the way for investments before 2030. Mr. Walter, may I add a second question from the audience, which you are probably best to answer. Why don't we use green kerosene as a drop-in fuel?
Schreibt das Herr Dr. Rolf Schicke von
Dr. Rolf Schicke from Renewable Energies Consult asked this question. Now, my statement and then an answer to the question. Over-subsidizing. I would like Mr. Eickholt gave a very impressive answer. It's not really about implementing an existing technology. When we talk about hydrogen technology, we have generation, which has to be scaled up and has to be redeveloped. And in aviation, we started in 2018 saying that we would invest in these technologies, which we would then be able to implement in 2030, 35. And these periods are still quite short, and we have to ensure supply of hydrogen at an early stage. Now, concerning the question that was just raised, on our path towards the hydrogen-based aircraft, we would use the fuels that he mentioned. We are already using fluids. They are based on biogenes. They're of a biogenic nature. And of course, it would be great to produce them in a green way on the basis of hydrogen in order to have an interim stage and an intermediate stage in order to meet the climate protection targets on our path towards hydrogen-based fuel. Now I have a question that looks back into the past, but that is good nevertheless. What did we learn from the failure of Desertec, failure in inverted commas, because opinions can vary? Desertec has also had an impact. For the audience, about 10 years ago, Desertec was a project, a major project, consisting of producing electricity in the desert with wind power and PV. Large lines had to be built to transport electricity in order to promote decarbonization in Europe. That's how the share of renewables was supposed to be increased. It wasn't really materialized. It wasn't really realized. We didn't really get very much electricity from the southern Mediterranean region. And the main reason, for my opinion, was that this region itself had to use their renewable energies to meet their demand. And of course, regulatory problems were significant as well. But what can we learn from the failure of Desertec? Mrs. Westphal. Well, you just mentioned, Mr. Schlandt, that we could learn that we shouldn't leap into a new energy era, but that we should define small steps. Secondly, it's also important that we have to think in terms of longer phases, that we should show more stamina. In my opinion, Desertec didn't really fail. Large solar power plants were built in Morocco. Egypt built up plants, Algeria as well, mainly used for local electricity demand, but we have lines between Morocco and Spain, and there are debates on new interconnectors from Tunisia to Italy or from Egypt via Cyprus to Greece. So the second phase of interconnectivity is just starting. And another area that we should learn from is having stamina and thinking strategically. The Desert Tech Industrial Initiative still exists, but many German companies left. The headquarters is now based in Abu Dhabi, and now China and Aqua Power and Saudi Arabian companies are involved. That's something that shouldn't happen in the future. When it comes to hydrogen, and with a view to PV, where we've really learned our lesson, we should make sure that this doesn't happen again in hydrogen. Thank you very much for this opinion. Would anybody like to add anything? And the very last question from the audience. We
teilweise recht kräftig vorgetragen von Herrn Peter.
I have already presented topics like regulatory issues. Mr. Peter was of the opinion that decisions should be taken quickly and should be more general and not be step-by-step based. But what are your wishes, your desires, your suggestions for a new and innovative hydrogen power policy? Hanna-Sophie Weber from JFNC would like to have an answer. Who would like to give an answer? Mr. Walter?
Let me start with Mr. Walter. Thank you. Even if I'm repeating myself here now, what is important is that we take action now. We often our politics always tend to resolve or decide things and announcing things and believe it's already implemented. There's a long road ahead of us. The whole research sector, the industry, infrastructure companies, and also politics and society as a whole. And if we don't act soon and discuss long, we will have problems. Thank you. Mrs. Grimm? Yes, maybe on that, a brief comment. Yes, we need to adjust our framework, as Mr. Peter said. I'll go along with that. We won't be able to manage that so quickly. So in the short term, we need to make certain adjustments as well, and this includes exempting the electrolyzers from the EED charges to save funding, and this sort of levels each other out if you do that globally for all energy consumers. But some decisions also need to be taken with regard to the role of blue hydrogen, which would help us significantly to accelerate the ramp-up and help us find pragmatic solutions. First, blue hydrogen, then green hydrogen, and various other adjustments. A lot of things that can be done, a lot of steps that could be taken now. We should focus on increasing transparency, making regulation easier, less complicated rather than more complemented, and then look into the future and ensure that the whole system can be more market-oriented, more market-based in the long term. Any more wishes to the new German government? You just mentioned the word or provoking word blue hydrogen. Mr. Goldschmidt has raised his hand. Yeah, please start. Yeah, thank you. Your comment about the new German government. The state-imposed prices were already mentioned. What is important is for the whole system to be financed, and it needs to be financed. We need to take action now, and if I ask the industry, what do you need to take action, then what they are saying very often is we need appropriate and a higher carbon price. That is what business are demanding now to get the business case right. So this is something that needs to be tackled sometime soon by the new German government. What we also need is a reasonable way of origin, proof of origin for green hydrogen, because we need the proof that the green hydrogen is really green hydrogen for people who are prepared to pay more for it. And we need an honest and a decisive discussion about the future market design. Is it really right to have one single power price zone across Germany, or should we accept that grids have power and this needs to be reflected in prices? Grids have borders, sorry, and this needs to be reflected in prices. And we need climate and energy foreign policy as well. That's very important because we haven't got that much time left there. And there too we need to take action as well. Everyone's nodding here, particularly Ms. Westphal. Great. A big thank you. Unfortunately, time's up. There were many more great questions here from our audience. So unfortunately, we have to leave them unanswered. Maybe there is an opportunity some other time, to check with the experts. For example, distributed hydrogen production, how to keep renewables attractive if the power price goes down, scarcity of water in Africa. So a lot of great topics. But unfortunately, time is up. So thank you to everyone here. I think it worked really well. It was a lot of fun for a digital format, a hybrid format. It was a great exchange and a very interesting exchange and discussion we had here today. So enjoy the rest of the afternoon. And I say bye to you. Now I wave to the camera. So thank you for being with us.